Hi, this is Dr. Leroy Always, and this is Grade School for Adults. Today I'm going to look at something really kind of fun, and that is how to identify factors and how to identify factors leading up to how to identify prime numbers and composite numbers. Now, a composite number is a number that is a whole number that you can divide by another whole number and get a whole number. And same thing with a prime number, but a prime number you can only divide by one in itself. For example, 2, you can divide you can divide 2 by 2, and you can divide 1 by 1. But if you divide it by anything else, you'll get a decimal. And a composite number, for example, is the number 12, where you can divide 12 by 1 and 12. You can divide 12 by 2 and 6, and you can divide 12 by 3 and 4. And so for 12, you get the factors of 1, 2, 3, 4, 6, and 12. All of those are factors of 12. Whereas 2, you get factors of 1 and 2. And if you get 2 factors, it is a prime number. Now, you only count the factors once. For example, 9. 9 can divide it by 1 and 9, and you can divide it by 3, resulting in 3. But you don't count the factors as 1, 3, 3, and 9. You count it as 1, 3, and 9. So you get 3 factors for 9. The interesting thing is the number 1. The number 1, you can divide it by 1 and get 1 and only 1. And therefore, 1 repeats itself, but you only get 1 factor. To be a prime number, you have to have 2 factors. You have to have 2 factors of 1 and itself. Now, even though 1 repeats, 1 is not a prime number. Now, the fascinating thing is to get it to be a composite number, you have to have 2 factors. And 1 repeats itself. So 1 is not prime, and 1 is not a composite number. What is 1? Well, 1 is a whole number. It's a counting number. It's a real number. It's a natural number. It's an integer. But it's not composite, and it's not prime. It stands by itself. It is 1. 1 is the loneliest number. Okay, so yeah, he makes jokes. Okay, so what I'm going to do is I'm going to pull up this chart. This is a chart, the 1 to 100 chart. You can buy this as a professional chart or a chart that you can hang up on the wall if you walk into your kindergarten class, pre-kindergarten class, first grade class, second grade class. You will see this chart. If you look at another video I made on mathematical aids, I show you this chart. I thought would be gone. I would not see it again after second grade or after third grade, but it has come back in fourth grade. And it's come back for a pretty good reason, because in fourth grade they're reviewing skip counting or reviewing properties. For example, what is similar with all the tens. And all the tens have a 0 at the end, and what they're leading up to is they're trying to look at this in terms of what are the factors of these numbers, because they're going to be leading to division. And so multiplication is very important. Knowing the up to the 12 by 12 multiplication table is in their head is extremely important for fourth grade, and it's something that you really want to work on leading up to fourth grade. But what we're going to do here is we're going to take a look at what numbers are prime and which ones are composites. And what I'm going to do is I am going to, for example, I said that 1 is not a prime or a composite, and I'm just going to mark that as a red. Now, let's go through and identify, and if it is a composite number, I am going to shade it. And 2, we can take 2 and divide it by 1. We can divide it by 2. It is a prime. We're going to leave it alone. 3 by 1, and we can divide 3 by 3. It is a prime. We're going to leave it alone. Now 4, we can divide it by 1, 2, and 4. And so we have 3 factors, so it is a composite number. And at this particular stage in the game, we do know that every single even number besides 2 is a composite number. So let's highlight the numbers. We get to 5. 5 itself is a prime. All the 5s, they are also composite numbers. Okay, so we have sevens and we have nines, and we're going to skip seven for now. We're going to go to the nines. Nine itself is a composite number, but there's also a thing called the rules of nines. Excuse me. Every number that's divisible by 9 or a multiple of 9, their digits add up to 9. For example, 1 plus 8 is 9, 2 plus 7 is 9, and so on. That rule of 9 carries over to the rules of 3. Every number that the digits add up to 3 is divisible by 3. And so that's even more powerful than the rules of 9. So let's take advantage of that. And so we have 2 and 1 and 21. And so we just can go right down through the list here really quick. Actually, we can go right down the 9's diagonal here. 27, 36, 40, 72, and 81. All of those are divisible by 9. Doing one other diagonal, the one that my kids like to do first before they do the 3's and even the 9's, and that's the 11's. So any number for the 11's on this table, any repeating number 2, 2, 3, 3, 3, 3 is divisible by 3 as well. So 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 7. 7, 7 is divisible by 11, and 99 is divisible by both 9, both 3, and 11, all those things. When we can quickly go through the 3's real fast, we have 2, 1. Also, by the way, if it's divisible by 3, it's even, it's also divisible by 6. That's called the rules of 6. So that's a special case of the rules of 3. So we're at 69, 71 is 8, 10. Now, the 7's. The 7's, it's nice to have all the 7's multiplied. 7 times 1, 7 times 2, 14 times 3 is 21, times 4 is 28. And this is how I do the 7's, because there is a bunch of rules for 7, and the rules for 7 are really, really chaotic. So I don't have those memorized. 35, 42, and again we hit 49, which we've seen a couple times. 49, and I believe we have it. Those are all the composite numbers on 1 to 100. And if we take a quick look on those, we add them up. We got 1, 2. There's 25. Again, the reason why I know there's 25 is because there are 25. And so these are the primes. 2, 3, 5, 7, 11 are the 100 that we see over here. Now, my kids, before they entered 4th grade, that is, they've already graduated from 3rd grade, already been promoted from 3rd grade to 4th grade, I was having them do this over the summer, learning these rules. We took it to 100. And I want to go up a little bit higher to 150. And so what we're going to do is we're going to take a look at the same numbers. We've already done 100, and quickly we're going to finish this table up to 150, and there's a couple things I want to show you, and there's a reason. Let's continue with the 11. So 99, 110. We hit 110 at 11, we'll get 121. And I'm going to show you a really fascinating rules with this. 121, 132, 143. Now, 11s have an interesting rule. Rules for 11 up to 99, the numbers repeat. And then after that, we have 110, 121, 132, 143. There is another, I will call it an observation for 11. Something that I think is really cool. It's not a rule because it breaks down. And that is, if you take the digits and you subtract, add, subtract, add, subtract, add, and if it adds up to 0, it's possibly, doesn't mean it is, it's possibly divisible by 11. And we can see that with all these. All of these we know. 9 minus 9, 0. We get to 10, or 110. 1 minus 1 plus 0. 1 minus 1 plus 0 equals 0. And again, so you subtract the middle, you add the end. You subtract the middle, you add the end. You subtract the middle. And all of these add up to 0. But it breaks down. But it breaks down in a really, really cool way. And that is at right here, 407. If you do the same rule, 4 minus 0 plus 7, it adds up to 11. So if the number plus minus plus minus plus minus plus minus plus minus all the way. It doesn't matter how long the number is. If it adds, if it sums up to 11, 11 or 0, it might, I'm not saying it guaranteed, but it might be divisible by 11. And so what we see here is divisible by 11. It go on down, it breaks down again. It now goes back to 0. We go down a little bit farther, it's back to 11. And we can do any one. 704 adds up to 11. And so we see that over and over again. All of a sudden, 7 minus 7 goes to 0. And even these bigger numbers, 9 minus 7 plus 9 goes to 11. You get down here to the 99 times 11. 99 times 11 is 1,089. And now we have a 4-digit. Again, minus plus minus plus. And so we 1 plus 9 or plus 8 minus 9, 0. It adds up to a 0. Again, it doesn't necessarily mean that it is divisible by 11, so you have to check. But it's one of those things where it is, pull out the calculator and say, hey, I think this is divisible by 11, and it just might be. So it's kind of a really fascinating rule on that. So, okay, so we did the 11s. Now, let's keep on going here. Okay, like I said, I'm not perfect. Shows me. Okay, and we have it, all of them. Now, like I said, there's a couple other interesting rules I want to just point out. And these are rules. These work all the time, and that's the rules for 4. And the rules for 4 is if the tens and 1 digit if that's divisible by 4, then the number is divisible by 4. So 24 divided by 4 is 6. The entire number, 624, is divisible by 4, equals 156. So that's kind of cool. If the last 2 digits are divisible by 4, it doesn't matter what the front digits are. Really, really cool thing to have. Another interesting one is the rules for 8. And the rules for 8 are if the hundreds digit and the tens digits and the ones digit, if they form a number that is divisible by 8, then the entire number is divisible by 8. So 032, well, the 32 is divisible by 8, that's 4. And so 1032 equals 129, divisible by 8. This is really a kind of a cool thing. And it's something that your kids should know if they're in the 4th grade. Not necessarily know how to find every single prime number, but how to know how to identify composite numbers, how to identify factors, how to identify what it is divisible by. And this will come into things like fractions, finding the least common denominator. So if you have a number there and you need to break out all the factors out of there and compare it to another denominator so you can find which denominator that they can possibly share, it's really important to know the factors. Okay. If you have any questions at all, put them in the comments. I will gladly answer the comments. If you like my videos, please subscribe. And I will continue to make more. And even if no one watches, I will continue to make more. Thank you very much. Bye.